Okay, so trying this again. Looks like the stream has started. I'm seeing that on my end. So hopefully that's not gonna crash again. And we have yet another URL for the stream. Sorry everyone about that. Just seems to be the name of the game today. Not sure exactly why. But hopefully, well, one thing I'm going to do is I'll keep my stream window open over here so that I can notice if it does dip out. But okay, so I'm going to pick up where I left off since I've already had a couple false starts here. This is get nth element of a value, where we're considering some dictionary, and we're going to put in a key name as well, and then we're going to, following that, we're going to put in an index for a list associated with that key. So let's call this key 1. And let's put in the index 3 and go with that. Not sure why I'm getting an error there. Huh. Oh. Of course that's why I'm getting an error. Okay, sorry. This whole stream business has thrown me for a little bit of a loop. So I'm going to make some dictionary called D1, and D1 is going to have some things in it. It's going to have, why don't I do this below? Okay, D1 is going to have something called key 1, and that's going to be associated with an empty list. Since we're trying to solve this first condition, if the list is empty, it should return none. And so here we have an empty list, and what we should get returned here is none. If I put in, call this key, not key 1, but key. All right. I'll call that IDX. I don't know why I actually put a number there. Okay, so print get nth element of value. Well, this is going to be D1, and the first thing that we can check is if this list associated with the key is empty, then we return none. So I can say if D sub key, well, that's a reference to the list, actually. So what I could say is if the length of D sub key is less than, well, if it equals 0, how about we do that just to be really explicit? If that length is 0, we can return none. Okay? So that's a condition that we're going to check first, and we can just see if this passes at this point. Okay? So let me just kind of set these up to be able to see them. So let me run this, python delme.py. We're returning none. Okay, so that condition is satisfied. I think that's where we're starting. And let's just work down this list of conditions. If n is out of range, it should return none. Okay. So what we can do, if the length of D sub key, we could actually just modify this. And, but you know, let me do this explicitly first, and then I'll show you what I mean. Okay, so here, let's make another dictionary, D sub 2, and this will have key, I'll just call it key 2, it doesn't really matter, and I'll put 1, 2, 3. So if we try to get the fourth index here, or sorry, the third index, so like 0, 1, 2, if we try to get index 3, that shouldn't work. We should return none. So if the length of D sub key, if we want to make this pass that condition, right now, this isn't really going to do anything for us, honestly. You know, we're going to get none in both these cases, but not for the right reason. So what I'll do here, if the length of D sub key is less than the index, then we should return none. So in this case, this should work for both of these. Well, you know what? I'm going to make this 2 separate conditions, you know, just to be very explicit. So here's my other condition. If this is less than the index, then that should return none. So here we've got 2 things that we're trying to pass. Oh, key error, key 2. None. Oh, because I'm passing in D1, I want to pass in D2. There we go. Okay, so we're getting none, none. We can see that this is working so far, and we can just continue forward. I think this is kind of nice when you just look at something condition by condition, or kind of test by test, and you try to solve that. If the property at the given key is not in the list, it should return none. Okay. So we can just copy this. And we'll use D2 again, but this time we're going to look for key 1, and we can leave the index the same. So if I say, if I'm going to do this, what I would like you to notice here is that if I pass in D2, D2 does not have a key 1. So we're actually going to error here right now, right? Key error, key 1. So that's because we're checking these keys, and the key doesn't exist in there. So we need to put this condition above. So if key is not in D, then we can return none. Okay? So that's something that we should do before the others, otherwise we're going to get some kind of error. So let's see if we get 3 nuns in a row. All right. I was just trying to think of a joke that involved habits because I'm saying none a lot. But okay, so we're on our way. Okay, if the so we solved that one. If the property at the given key is not in the list, it should return none. So we are doing that. If there is no property at the key, it should return none. If there's no property at the key, I think what they mean here is value. If there's no value at the key, it should return none. Oh, don't know what's happening there. Okay, so why don't we solve for that? Here, let's do this here. If D sub key is none, return none. This is not, I think this is what this is asking for. So let's just make another, let's make a D3 here. And we'll do that. And change that to D3. All right. Okay, so here, I believe we're just checking to see if there's no value associated with the key. I'm assuming that's what we're doing there. Maybe we'll find out that some test that we have that we're actually trying to do something else. But but we'll find out in a little bit. Okay. So those are all of our sort of edge cases. And what we really want to do is just return the nth element of the list associated with any key. So let's make D4 here and make this very simple. 1, 2, 3, do 4, 5, 6, 7, 8, and we'll just see how this goes. So D4, and we're looking at key 2, and we want to get the index at 3. One thing that's a little bit ambiguous here, get nth element. When I think of the third element, I actually think of the fourth index. So it's not clear to me if we're asking here for the third, index 3 or index 4. And so we'll discover that when we actually run this and learn. So my expectation here is that 0, 1, 2, 3, this last one should return 4, right? And to make that happen, I can just do return D sub key sub index, okay? That's my assumption. It's either going to be sub index or sub index minus 1. So let me just make sure that that runs. Oh, list index out of range. For which, I guess for the last one, right? Actually, I think we're throwing that error on the second one. Let me just see why. Okay, so we pass that first one. I think it's the second one that we don't pass. Indeed, it is not. Okay, so we must not be catching this. So if length D sub key is none, okay, if length of D sub key is 0, if the length of D sub key is less than the index plus 1, I believe is what we want to do there. Okay, so that's a bit subtle, but if we're considering which one is this? We're considering key 2 here, right? And we're looking at 0, 1, 2, index 3. The length of this is 3, but we only go up to index 2. So I believe this actually accounts for that. We're going to say if D sub key is less than or, I just did index plus 1, but I could just do less than or equal to, it makes more sense. It's a little nicer. Okay, so let's try each of these in turn, just to make sure that the rest of these are still working. And then we're getting 4, which is what I think we should expect. All right, so I'm gonna throw this into learn, and hopefully this works. But if it doesn't work, I think we'll be able to figure out why. So let me snag all of this. All right. So here's that problem, and let me just run this and see if we pass. We did not pass. Okay. Object of type int has no length. Huh. Interesting. Okay, so let's look at this. If the property of the given key, if there is no property at the key, it should return none. Okay, so we're failing. think maybe we need to check to make sure that D is actually a dictionary. Or not, if the property is not a list. Okay, we're not checking to see if it's not a list. So I would just add into here, let's do if D sub key. I could do if not is instance, D sub key list. I think that should take care of that condition. Okay. Huh. Interesting. I'm going to take this back over here to my text editor. Some of these practice problems, I'm just going to be frank, I'm not a huge fan of. It's a little, I think a little unclear sometimes what we're asking for. And so how about we do something like this? Let's do a D5. And we have a key, and then we have an integer. And let's test this against D5 with key 2. And I'll comment the others out. Okay. Not entirely sure what this is asking for. Let's see. All right. Object of type int has no length. All right. Object items. It's here. So, oh, I didn't return none here. I just need to return, okay. I typed it wrong. Okay, all right. Sorry, that error may not have been entirely clear, like why I was getting a wall there. Notice here on line 7, I'm not returning none. I'm just saying none, which doesn't actually do anything. Okay. So just to recap what I did here, I just took care of each of the conditions as I understood them. And one of those conditions was checking to make sure that the object, the dictionary had associated with it a list for the key that's being referenced. So if it's not a list, if not instance D of key or D sub key is a list, then we're going to return none. And I had put none there, not return none, which is a, just an oversight on my part. So I hope that answers your question. Kind of let me just scan through what you've got here. Yeah. Because you are first checking for the length of the list, you're going to get an error when the thing in there is not a list, right? That's kind of that's going to happen. So you kind of have to arrange these in a way that that accommodates your errors, your potential errors. So I hope that helps, though, with seeing that. I'm trying to think of another example that would have a similar result. Well, here's the funny thing. You know, if we can be confident of the data that we're passing in, you know, the dictionary that we're passing into this get nth element of value, we don't need any of these, right? We could have some kind of one-line function, and if we were confident about what we're passing into, it would be fine. But I think what this challenge is actually getting at is like, hey, we're not really sure about what's going to get passed in here, so let's make something that is a little bit bulletproof. That's in the real world, you tend to write code a little more like that. Although, you know, we could probably condense this somewhat if we really wanted to. But yeah. Here, let's kind of traverse around in here a little bit. Let's look at the tuples since we're kind of in that area. Let's see if there's a interesting challenge in here. Okay, I think this is interesting. I think I'll just go through this problem. This is under tuples are immutable in the tuple section. And let's just look at the problem statement. So complete the function called insert at index 2 that takes a tuple called tup and an integer called x. This function should return a tuple where x is in the tuple at index 2. Okay. You can assume the tuple will contain at least 3 elements. Okay. So why don't we start with that starter code. And notice we've got a doc string here we can kind of look at. Returns a new tuple where x is inserted into the original tuple at index 2. All right. So I think the first thing we usually want to do is write something like a test. And let's do 1, 2. We're just going to make a data structure here. We need to have an index 2, which is right here. Index 2 is, you know, I'll actually just put index 2 as something that we're going to replace. And x is going to be inserted where index 2 is. So let's just define an x, call it cat. And then we can do our function call. We'll print this. And we're going to take that tuple, and we want to replace whatever that is with index 2. Okay, so what we can do, well, what I'm going to recommend doing is we just take that tuple and we cast it to a list, and we reference 2, index 2, right, which is the third element, and we just put in there x. So that's the first thing we can try. Oh, let's say, let's call this return tup, and we'll cast that to a tuple ultimately. Oh, oops. misthinking this. Let's do this and call this updated. I'm just going to do this in a couple steps. So updated, we'll get a list of that, and then updated sub 2 is going to get x, and then we can just return a tuple of updated. And I think that should satisfy what we're trying to satisfy. So let's run that first. So 1, 2, cat 3. And let's find out if this passes. Oh, it did not. Okay, so why are we not passing here? Oh, 1, 2, cat 3. I just pasted in way too much stuff. Let me try that again. Okay. First extra element, 6. Okay. I think this this problem's a little different than what I thought. So so we should be sort of expanding the tuple that's passed in. Okay, so let's do this. That kind of changes things. Let's say that there's the low part of the tuple, and this is going to be the tuple sliced from 0 to index 2, and there will be the high part of the tuple, which is going to be the tuple from 2 until the end. And then we can just say low.append x, and then we can return just return low plus high. I can't remember offhand if these will cast to list or not, but let's just find out. Okay, let's see. I think my syntax is probably a little wrong here, but let's find out. Tuple object has no attribute append. Of course it doesn't. Let's cast these to list. Okay, so I think maybe this is what is being asked for. This is the thing about writing challenges, is that sometimes, well, sometimes it's you know, a little ambiguous what's being asked for. So let's see if that is going to work. Oh, okay, yeah. So that's what was being asked for. There's a nice, very brief solution here, which, you know, is absolutely okay as well. Turns out you can actually use concatenation with tuples, and it looks like that makes a new tuple. I wasn't aware of that. So if we were to think about that, we could do. Make this a one-liner. And so we get that first range from 0 to 2, And then I assume we're putting x here in a tuple of length 1 to allow it to be concatenated with the other tuples. Unmatched paren. That makes sense. And that works as well. So that's a more elegant solution. Wasn't actually where you could do that. A little bit more kind of Python syntactic sugar. Sweet. Okay. All right. So I think there's actually a fair amount of lag happening on this stream. Sorry about that. I think I got a message back about 4 minutes later, a few minutes ago, or about 7 minutes ago. But I think that should be, that should also be an all right thing. So as soon as you have a question, I guess that means just like throw your question in there so I see it sooner than later. Unfortunately, we're sort of at the end of our nearing the end of our interview cycle, which means that we're going to be a little brief with study halls in general. We're going to try to keep them to about an hour for the next couple weeks, but they're generally an hour and a half long, maybe hour and a half to 2 hours depending on the questions that are coming in. That said, I think we've got time for I think one more, so let's look at this one. Tuple creating tuple. This function takes 3 arguments called nameTup, ageTup, jobTup. The 3 tuples are in parallel since they contain the same number of items, and each item at a given index corresponds to the other items at the same index. Index 0 across all 3 tuples holds the name, age, and job of the first person. Index 1 holds the name, age, and job of the second person, index 2, and so on. This function should return a single tuple where all of the values at a given index are tuples of the data for the same person. Okay. Okay, I think I get this. This is one of those problems where, we're not giving you anything to test with, so it's going to be helpful if you work on something like this to create your own data. So first I'm just going to write the function header, tuple creating tuple, and there are 3 parameters: nameTup, ageTup, and jobTup. And let's go ahead and do that. Okay. All right, so the assumption here is that these are parallel, right? And nameTup, we'll just do 3 items for nameTup. So this will be, Sean, Rose, and Larry. And then ageTup will be 27, 37, 47. JobTup will be broker, minor, and clown. Okay. So the idea here is that it's going to go Deshaun 27 broker, Rose 37 minor, Larry 47 clown, and all of it will be a single tuple. So the first tuple will be Deshaun 27 broker. Okay, yeah. So let's construct a tuple. So I'm gonna start this off. I'm just gonna make this a list to start off with. Is that what I want to do? Yeah, I think I want to make a list. And I'm going to say for IDX in range length of the nameTup, the assumption here again is that these are all parallel. And you know what I'm going to do here? Let's print the result of that. Getting some error. Oh, I see why. Right? Yeah, that's fine. Okay, so we've got this index, and what I can say is just out list dot append, and I can just take name tup. I'll just actually grab all of these since they're sort of in the form of the tuple anyway. And I will put for each of these the index. And then, so that should build a list. And why don't I return this out list first, and let's just see what that looks like. So Deshaun 27 broker, Rose 37 minor, Larry 47 clown. We actually want this to be a tuple, and if I want to do that, I can just cast it to tuple. So that should work. I don't know that this is the best solution. It's just what occurs to me offhand. You know, a quick and easy way to accomplish that. And I'm sure when I run this, there will be a solution that's also provided that might be a little better than this. So let's find out. Ah, no, that's basically the same solution, just with slightly different names. So, yeah, here we go. This is a good one. Zip is nice. So, in this case, here, I'll just show you. I really don't use zip enough. I think part of the reason is that coming from other languages where we don't really have a zip function like this. But if we want, why don't we see what this looks like? So we're going to zip all of these, and why don't we print that? And yeah, zip kind of does the work of a for loop here. Oh. Let me uncomment that. So we were getting a zip object here. If I want to see this as a list, which is actually what I want to look at, this will give us a clear sense of what's happening there. So zip is just taking, it's assuming all of these are parallel, right? And it's taking each element and it's just sort of like putting them together, right, into tuples. It just gives us, we will use this sometimes in a for loop, you know, that can be, that's often a place where we see zip being used. But, you know, this is actually just constructing a really effective data, you know, data representation for us, which I think is nice. Yeah, I should definitely use zip a little bit more. All right. Okay, so I'm going to spin down for today. Sincere apologies for the technical delays. I'm still not clear on what was causing that. I know that we've had that kind of issue in the past with YouTube, but I haven't seen it in a little while. Hopefully that's not something, or hopefully that is something on our end that we can repair, not something just that is going to happen periodically with YouTube streaming. But again, you know, we'll find out. We'll see if that is the case. Hopefully it's not the case. And, you know, we'll be able to just start on time and do that thing. So thanks so much, everyone. My name is Tovio Roberts, and reach out if you need anything. We do this Monday, Wednesday, Friday. For the next, you know, bit of time, we might try to keep these at about an hour, since we've got a lot of interviews that we're doing and a lot of like last minute stuff that we have to take care of. But you know, we'll see. Oh no, I think I have a Galvanize logo in front of my face. I didn't realize that. Okay, that's something else I'll try to I'll try to repair. I'll try to take care of. Okay. Thanks so much, everybody. Bye.